I will do that in next lecture. Next lecture, I will calculate for you the omega for very easy case for the classical gas, ideal classical gas, no interaction and nothing. I will do that. So, to be done in next lecture. Now I wanted to do the easy work. The easy work is that we know that the entropy is some functional form of this accessible state. So I wanted to impose simple basic rules. Find S. I do the Gedanken experiment. Just mentally experiment. We have a system with number of the state omega. I don't know that how you find this omega. We have this number of the possibility in your system. And this omega is function of energy and volume and everything. So basically this is the number of the possibility for the system with n particle fixed in the box. The volume of the box is V and then it fixed in the spatial temperatures. You can be like that. We will do that later. Make a partition to the system. The number of the possibility here will be omega 1, omega 2, omega 2. But the entropy for that, entropy is S, huh? The S omega total should be S omega 1 plus S omega 2. This is called additivity. Not all form of the entropy and not all the system follow the additivity. But most of the system, if they iterate in the equilibrium, they are considered as a system with additive entropy. I mean, not always this equation. We have some case which they are not considered as equilibrium and their entropy doesn't follow that. But this is basically, it's basically looks like something like in the set theory in the mathematics. So this comes from the set theory actually of the math. Remember it. Yes?
From the experiment?
Gedanken experiment. So this is a German name. So it means that some mental experiment. Just you thinking in your like what you are doing in the spatial relativity. You're talking that the photon is going a Doppler effect, something, but you never can see that directly photon. You never can feel exactly what the photon is doing. So you just sit like the photon and they go and do this process. Also in the quantum mechanics. Okay, just accept this additivity principle. And I told you I inspired from the set theory, in number theory, in algebra. This is the total possibility you have. R, yes, divided by B. So is the omega total. So in your case, it's omega 1, omega multiplied to omega 2, the number of the possibility. And S omega 1, it looks like the number of the elements of the set A. And S omega 2 looks like the number of the elements in the set B. So you can use this equation from the set theory. Not equation, this identity from the set theory. So look at that. So my aim is that to solve this equation. Yes, if I can solve this equation, I can get the S. How we can solve this equation? Actually, that was the The first example, the first homework I did when I was a student with this course, around 15 years before. So, how I can solve this equation? What is the form of this equation? Is it differential equation or something like that? No. You know, differential equation is like that. Huh? Dy by dx is ax y plus bx at the first order. I mean, this is called a differential equation, yeah? Differential equation. You have not differential equation, you have a difference equation. For example, an plus 1 minus an is common. This is called a difference equation. I don't know, you see that this equation before, no, difference equation. You have a different type of the equations. And you have one more class of the equation, of course the simplest case. You have a partial differential equation. Like the famous one is the wave equation in the one dimension. This is a partial differential equation. This equation never looks like any of this class of the equations, yeah? This is a functional equation. Functional equations, and generally speaking, solving the functional equation are very hard. Sometimes we have a functional differential integral equation, we have functional differential equations. So this is the field of the mathematical physics. We have a lot of interesting questions which can be formulated like the functional equations. For example, the whole field theory, quantum field theory, can be considered as a functional theory. And in condensed matter, you have many systems can be considered as a functional systems. So the strategy is that to convert the functional equation to the differential equation or difference equation or partial differential equation. This is the strategy. So the strategy is that if you have a functional equation, convert that to partial differential equation or something else, something which you know that, or ordinary differential equation, ODE, and or differential equations. If you be a bit good in the math, you can find it that a strategy to convert this equation to the partial differential equation. I do very strange things is that I take the derivative from the omega 1 from this equation, from both sides. So this partial derivative means that you fix it the omega 2 and just make it the derivative with respect to omega 1. If you take the derivative of that, what will be, you can use the chain rule. Will be omega 2 f prime, and that will be df, d omega 1. And this do same, but instead of the omega 1, take the derivative with respect to omega 2. So it will be omega 1 f prime. This is the cumulative index. When I write prime means that derivative to respect to the whole things. So you can call it this u. So f prime omega 1 omega 2 means that df day u, according to the chain rule. So this is will be df